Okay, while we are waiting for others, okay, I have highlighted the one in yellow, okay, for the notes, okay, the later on notes, okay, for question notes number 4 and notes number 5. You can copy it down first, okay, copy it down.
Teacher, we have to draw.
No need. I got mute mic Okay, copy down this one The one for yellow, the one that I've highlighted yellow. Okay, number 4 and number 5. Okay, done? Yeah, I see got how many. Okay, if you cannot enter, okay, don't worry, okay, because every end of one chapter, okay, I will upload this video maybe either using YouTube or Facebook, okay? So I will share the link with you, then you can use this as a reference, as a revision later on. Okay, clear? Okay? Okay, so if you compare a specific heat capacity for a solid and a liquid, generally liquid will have a higher specific heat capacity than solid. So which is why you see the diagram below. If you heat up the same mass of water and the same mass of concrete, water is representing the liquid, concrete is representing the solid. Okay, so for water, you see it needs 4,200 joule of heat in order to increase the temperature by 1 degree Celsius, which is from 20 to 21. But whereas for concrete, okay, it just needs 850 joule of concrete in order to increase the temperature by 1 degree Celsius. So which means that the lesser the heat needed for an object, we will say that the object has a smaller specific heat capacity. So you see here, if let's say you compare a solid and a liquid, solid will have a smaller specific heat capacity than liquid. Okay? So if let's say an object with a smaller specific capacity, it will reach a particular temperature faster when it's heated. So in another word, it will heat up faster. Okay, it will heat up faster. At the same time, it will cool down faster as well. Because, okay, for a solid and a liquid, a solid, it need, for example, concrete, it need 850 joule to increase the temperature. At the same time, it just released 850 joule of energy, heat energy, is able to reduce the temperature already. Okay, so in another words, smaller specific heat capacity heats up faster, cools down also faster. Okay, clear here? Okay, can I continue? Yeah, I continue. Okay, so now, why getting smaller, lesser and lesser people want? Okay, so this is a list. Okay, usually don't worry. Okay, in your exam. Okay, if let's say they ask you to find specific capacity, this specific capacity, the value will be given. Okay, so as you can see, liquid, for example, water, alcohol, they have a higher specific capacity. So which means that it needs more heat to increase the temperature. So it will heat up slower. Okay, but if you were to refer aluminium and the copper, okay, which is solid, okay, they need lesser heat, okay, as compared to liquid. So solid will have a smaller specific heat capacity. Okay, can okay. So I think this one you can refer to yourself Okay. Huh? Wait. Alia, why? Where, which part you don't understand? Alia, you say ha ma. Then I thought you don't understand anything ma. You understand Okay I know. Okay, good. Okay, so for this part, okay, for this slide I want you to focus on question 4. Focus on question 4. Okay, so for focus on question 4 Okay, I want you to read through first this question. Okay, the answer is 53. But how are you going to do it? Okay, you try and see first. Then later on, I show it to you. Okay? Can? Okay, so now this part. Okay, So this part, Okay. So we have 2 cups of water. Okay, we have 2 cups of water. Okay, we have 2 cups of water. Okay, 1 cup of water. Okay. Okay, 1 cup of water is 200 gram. Okay, with the temperature at first is 0 degrees Celsius. Then another one is 400 gram. Okay, with the initial temperature is 80 degrees Celsius. You see here, assuming there is no heat loss to the surrounding. So this is always we will assume in chapter 4 question. Okay, so the question asking what is the final temperature of the mixture. Okay, as you know, when the 2 liquid mix together, they will have thermal contact. When they have thermal contact, until a certain level, they will reach what? Thermal? 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 Thermal what? Equilibrium, correct. It will reach thermal equilibrium. equilibrium. When you reach thermal equilibrium, which means that both the final temperature is the same. Not only the final temperature is the same, the amount of heat, okay, can hear me or not? Can hear me? Okay, the amount of heat, okay, in both liquids also will be the same. Okay, because remember, temperature is the measurement of heat energy in a particular object, okay, in a particular liquid or in a particular object. So both of them will have the same heat energy already. So just now you have learned one formula relating your heat energy, which is what? M C delta. So here you will have two liquid, this one is liquid 1 and this one is liquid 2. Okay, so the liquid 1 and liquid 2, when it reach thermal equilibrium, both of them will have the same final temperature and also the same amount of heat. So we can use this, okay, as the comparison. This one is the 1, okay, then this one is the 2. Okay, so for 1, what is the mass of liquid 1? 200 grams. But we need to change it into what, and what is the answer? We need to change it into hello. Okay, I say that. Don't want to waste time now, okay? So it will become 200 gram. You must change it into kg. So 200 gram change it into kg. It will be 0.2. Okay. Then the specific capacity given already will be what? 4,200. Okay, then the change in temperature, this one initially is 0 degrees Celsius. So when you reach the final temperature, sure it will be the final temperature is more than the 0 degrees Celsius already. So how do you find the change in temperature? As I said just now, always it will be greater value number minus the smaller number. So you will use T2 minus 0 degree. Okay, so equals to the second, okay, second liquid, it will be 0.4 times 4200. Okay, then the change in temperature, same here. One is will increase in temperature, another one it will reduce in temperature. Okay, so the 80 it will reduce, become to the final temperature already. So if you compare the 80 degree and the final temperature will be lesser. So you will use 80 minus T2 to find the change in temperature for liquid 2. Okay, so you you solve this equation already, then you will realize that the answer is 53 degrees Celsius. Okay, clear? Can follow here? Yeah. Okay, good. Okay, so shall we continue a little bit? Okay, we continue. Okay, can. So this one, I think because this one is in the slide already, okay, you can refer to the slide later, okay, for your revision as well. Okay, so now this one, okay, next one, this one, to determine, we need to know the way to determine the specific capacity for a solid and for a liquid. For solid, we will be using aluminium, okay, to take as example to determine the specific capacity. Okay, then for liquid, we will use water. Okay, so when school reopen after this MCO finish, okay, I will do an experiment with regarding to this one, okay, to let you understand about this process, because sometimes the question comes out will be related to this question, this process. Okay, so this is a video, okay, relating how to determine the specific capacity of an aluminium. So I think it's better I will show you already, then you see what is the importance inside. Okay, just a flow only lah. But after school reopen, I will do this experiment with you. Okay.
We can use the apparatus shown to determine the specific heat capacity of aluminium. First,
So this is an immersion heater. Okay, immersion heater.
Via the joule meter. Then, insert the heater into the holes of the aluminium block. Put a wooden block under the aluminium block to reduce heat loss.
Okay, so this is the aluminium block, and you will see two holes here. One hole, the bigger one, is for the immersion heater. Another one it will be for thermometer.
Then, insert the thermometer. Record the joule meter reading.
Okay, joule meter reading is for the heat energy. Okay, for the to measure the heat energy.
Aluminium block at this moment. Then, switch on the power supply to heat up the aluminium block. When the
So we'll heat up until a certain temperature. Okay, maybe 10 degrees Celsius. Then we see what is the time taken to heat up.
Record the joule meter reading again. Then, use the recorded data to calculate the specific heat capacity of aluminium.
Okay, so this is a way to find the specific capacity of the aluminium. Okay, so for this part, what I want you to take note is the diagram here. Okay, the diagram here. Okay, the diagram here. Okay, usually the question will give you this diagram already. They will ask you some question inside. Okay, so here the bigger hole is to put your immersion heater. Okay, to heat up the aluminium. Okay. Then the thermometer here is put in another hole. Okay, before you put a thermometer, you must put a few drops of paraffin oil into this tube. Why is it you want to put this paraffin oil? Is to provide good thermal contact between the bulb and the aluminium cylinder. Okay, so as you know, if let's say you put the thermometer without the oil into the holes, okay, the hole is surrounded with air. If you compare air, a gas with a liquid, liquid is a better transferring the heat, okay, than gas, okay, because the particles are closer to each other. That's why we need to use paraffin oil as the medium for good thermal contact, okay. Whereas the aluminium block and this wooden aluminum block will be covered, okay, with a cloth. We will call it as felt cloth, okay, and it will put underneath the aluminium block is the wooden block. Okay, so the purpose of putting these two is to reduce the heat loss to the surrounding and also act as a heat insulator. But if let's say a question asks you what is the purpose of the wooden block and the felt cloth, it's better you write it down, reduce the heat loss to the surrounding, because this is the main purpose why, because this is the precaution we need to do, okay, for any experiment related to heat. Okay, so I want you to write down this one, okay, to determine, okay, this one is your notes number 6, to determine the specific heat capacity, okay, of aluminium. Okay, then you write down these two notes, okay, lagging with the felt cloth and the wooden block is to reduce the heat loss to the surrounding. Then the paraffin oil is to provide a good thermal contact. Okay, clear? Can or not? Don't sleep, ah. Okay, I let you have 1 minute to copy down, ah. Open mic. Uma, close your mic. Yeah, thank you. It's okay. Hey, your chemistry using Zoom. Then your MS also using Zoom. MS Meet. I prefer Zoom lah, because Zoom you can record down the video. Teacher, yes? Why? Christina? You ask me? You are fighting me? Why? What happened? Or later on, you can refer to your slide notes, slide 8. Okay, or wait, others, wait, okay, Uma send her later. Thank you very much. Okay? Can, is that I continue already, since you all already take note already? Okay, so this is the setup to determine the specific heat capacity of water. Okay, same. Okay, you have a beaker of water. Okay, a beaker filled up with water. Then we also have a shield. Okay, shield with the wooden block. Both of these have the same purpose, is to reduce the heat loss to the surrounding. Okay, then the lid here also the same thing also. All this, the main purpose is to reduce the heat loss to the surrounding. Okay, reduce the heat loss to the surrounding. But here, got a stirrer here. What is the purpose of this stirrer? Okay, what is the purpose of this stirrer? What is the purpose of the stirrer? Yeah. Leo.
To measure the heat increase
Good.
evenly.
This one is stirrer, or stirrer is like your spoon. Yes, stirrer is to stir. Yes, stir is to stir. But why you want to stir it? Okay, so yes, correct. To spread evenly, to have an even heating around the liquid. Okay, around the liquid. Correct. To ensure the temperature increase evenly, or to have an even, okay, heating. Okay, even heating. Okay, with this even heating, then only you can get a more accurate reading. Yeah, can Okay, now we will go to the last part. Okay, last part of the specific heat capacity. Okay, it will be the application of specific heat capacity. Okay, so since we know that heat capacity, it will have if you have a smaller specific heat capacity, it will heat up faster. Okay, it will heat up faster. Also, it will slow. If let's say heats up faster, and also it will release heat faster as well. Heats up faster, cool down faster. Okay, if let's say a higher specific capacity, it will absorb more heat. Okay, then only it can increase the temperature. So which means that it will heat up slower. So what we have learned about specific capacity, we will apply in our daily life. Okay, so these are the 6 part. Okay, example which are applying specific heat capacity. Okay, building material, okay, of a traditional house, household device and utensil, sea breeze and land breeze, okay, which happen at the beach there, beach side there. Okay, outer layer of the space capsule, production of the material in the construction of green building, and also cooling system of a car engine. Okay, so now I will explain it one by one. How does this 6 example applying specific heat capacity in building in this 6 example? Okay, so the first one is building material. Okay, building material of the traditional house. Okay, so rumah Melayu. Okay, in old times. Okay, in zaman dahulu lah, and also some of the houses in a cooler country, for example, Switzerland, everything else, okay, they will make their house which is made out of wood. Okay, why we use wood to make all these houses? Okay, because wood has a high specific heat capacity, so it will get hot slowly. That's why those that staying inside a wood, the house which is made out of wood, you will feel cooler because it need wood. It has a high specific capacity, so it will absorb more heat. That only it can increase in temperature. Since it has high specific heat capacity, so it will need to absorb a lot of heat. That only it will increase in temperature. Same goes to the houses at a cooler country. Okay, for example, Switzerland. During winter season, why they will feel cooler when they stay inside a wooden house? Because wooden house, as you know, wood has a high specific heat capacity. As I said before, it will absorb heat slower. At the same time, it will release heat slower. So it will be like an insulator of heat. So you will feel warm staying inside. Okay, a wooden house. Okay, can very well. Okay, so next. Okay, next is about the cooking utensil and the pot, okay, devices and the cooking utensil. Okay, so what you can see over here is usually, okay, what we have seen here, our pot, okay, our pan fry, okay, everything is made out of what? Made out of what? Made out of plastic, made out of glass, made out of wood, made out of aluminium. Which one you think is made out of what? Correct, aluminium. Okay, made out of metal. Correct. Okay, why is it made out of metal? Because if you compare metal with other material, metal has a lower specific heat capacity. We want it to have a faster heating so that it will be easier for you to cook. You can cook faster, then you can boil soup faster. Okay, that's why for the body and the base of a cooking pot, okay, you will use a material which has a lower specific heat capacity, for example, aluminium and copper. But for base, we will use a one that has a much lower specific capacity, which is copper, because it heats up very quickly. Okay, then the body, aluminium, same, lower specific capacity, it will heat up quickly so that your the food inside will cook faster. Okay, but for the handle, you want to grab it, okay, when it's heated, okay, when you are heating it, or you want to grab it from one place to another place. If let's say it is low specific capacity, it will absorb heat faster, so it will heat up faster, so it will burn your hand. That's why we need some material which has high specific heat capacity, for example, plastic. Okay, so that you won't it will be poor in heat conductor, so it won't absorb heat faster, then you won't feel hot faster. Okay, can okay. Next, it will be sea breeze and land breeze. Okay, for this sea breeze and land breeze, I will take a longer time to explain to it. But since now we still got 9 minutes left. Okay, same, you go out again, come back again. Okay, cannot go out, come back. Okay, see you later. Go out and come back. Ui, sự mà chân sọc